Like 7.
Safer. So it still keeps it edgy.
This thing always happen.
I'll send you an email.
Sasaki and Takaki. Mrs. Fujinaka said something about you guys were already supposed to talk to me already.
Oh, about class registry.
No. She sent me that email last week. Yeah, I know that. But she said you're supposed to talk to your teachers about making up work. No, you make it up. I mean, if you miss class because of whatever, you're responsible for the work. Yeah, that's how it works. So if there, I don't know exactly when it is, but if there's a test during the time you're gone, you gotta take it before, not when you come back. Okay, so we have a quiz on Wednesday and Friday. Probably the test is next Wednesday. This Monday's a holiday. Okay, today we still do, oh, we start 3 dimensions tomorrow. Yes. You don't forget your iPad. Where is it? Oh, on C?
Yes.
What's going on?
We just want Kevin.
What do you have? All your stuff.
Well, what does that say?
This is my.
There is none.
It's because you gotta draw.
Yeah, we did draw.
Okay, here.
Okay.
A, B, C. AB plus BC plus CA. If you have to draw a vector from here to there, it's nothing. That's a 0.
Okay.
There's nothing. It's the 0 vector. That's not even right. It's just nothing, because they all cancel out, right? There. Number 2, 2b. 2b. Okay, did you draw a parallelogram? A, B, C, D. Angle A is 60 degrees. What vector, okay, compute AB plus BC. So this plus this equals that, correct? So you have to compute the length of this. Why don't we call this x? And we know this is 10 and this is 6. If this is 60 degrees, isn't that 120 degrees? Because these two are parallel. Consecutive angles in a parallelogram are supplementary, right? So if you know 2 sides and an included angle, how do you find that side right there? Law of cosines. X squared is equal to 10 squared plus 6 squared minus 2, 10, 6 cosine of 120 degrees. And I don't think we even need a calculator. Doesn't it come out to 14? Yeah, no calculator needed. Because you guys know cosine of 120 degrees is negative half, right? It comes out beautiful, no calculator needed. Or did you guys componentize? Yeah, either way, componentize or use the law of cosines, comes out the same. Okay, number 3, good. Okay, that airplane problem is probably going to be on the quiz. Make sure you can do it. And then number 4, okay, this problem is on the quiz. You don't even have to ask. How many people got it? 1 person. 2. Is that it? Oh my goodness. See, that's why we're having problems. Did you guys look at the example? There's an example in the notes that like tells you how to do this.
No.
You guys are in deep trouble already. We're not even to the heart. Oh my goodness. H lies on DF. so that DH to HF is 1 to 2. So the ratio is 1 to 2. G lies on EH. No, wait. G lies on EH. Oh, this is EH right here. So that EG to GH is 2 to 1. So this is 2 to 1. If vector ED is V and vector EF is W, you got to make it point in the right direction now. Express vector DG in terms of V and W. Okay, this problem's on the quiz. Okay, the only thing I'm going to change, instead of 2 to 1, I'll make the ratio 2 to 3 or 3 to 1 or something. It's going to change. But the problem is the same thing. Okay, so somehow you have to write this vector here in terms of V and W. So basically you got to ask yourself, see, in a triangle, you have to know this plus this equals that. If you don't know that, you can't do this problem. See, like right here, DG, this vector here belongs to what triangle? Either this one here or this one here, right? So somehow you have to like figure out, okay, this belongs, like if you go to this triangle, then you need to like write this one as a vector. So then so if the vector pointed, for example, this way, then you can go this plus this equals that. You know what I'm talking about? Because look, there's so many triangles here, you got to be able to form this thing right there. So let's go to the very beginning. Okay, do you want to form vector DF or FD? Doesn't matter. Which one? Which way do you want it to point? DF or FD, pick one. Okay, DF. Okay, now look at the big triangle. Look at the three vectors that are there. What plus what equals what? This plus that equals this. So V plus DF is equal to W, which then of course means DF is equal to W minus V. You have to get the vectors pointing the right direction. Like if you made it point this way, then it would be this plus this equals that. Because I remember at past year, some students, they're not even drawing in the vector. So how do you know which way it's pointing? Okay, now that we got DF, okay, so look at this vector right here. Look at vector DH. What can you say about vector DH? It's 1/3 of vector DF, right? Look, it's pointing in the same direction, except it's just 1/3 as long because the ratio is 1 to 2. So if I change the ratio to 2 to 3 on Wednesday, what? Then what would this be? 2/5 of the whole thing, right? All I'm doing is changing the ratio. So DH is 1/3 of vector DF, but vector DF is this. Okay, why don't we simplify that? 1/3 W minus 1/3 D. Are you guys following? Okay, now we got this. Now notice that this belongs to this triangle over here. So if I form this vector there, now look at this triangle. What plus what equals what? This plus that equals this. Right? So let's write that down. V plus this, which is what? That's this thing right here. 1/3 W minus 1/3 D is equal to EH. So if we simplify that, vector EH is equal to, what is that? 2/3 V plus 1/3 W. Okay, now, see, now we're closing in on the thing. So now there's two things you can do. You want to do vector EG, which belongs to this triangle, or you want to do vector GH, which belongs to that triangle. Which one you want to do? Pick one. GH or EG? It doesn't matter. See, look, if you pick this one, then this one will be 2/3 of the whole thing. But if you pick that one, then that'll be 1/3 of the whole thing. So you gotta pick one. You guys can't even pick. You guys acting like period 3 now. It just sits there. It's there. Huh? Okay, you gotta. This is the basic. This is the ABCs right here. This plus this equals that. Okay, So what you have to do is you have to form vectors that make a triangle. So, like, for example, if you put this one here, okay? Look at this triangle right here. What plus what equals what? Huh? Okay, this plus this. Exactly. And you just keep doing it over and over again because there's plenty triangles here. So you just gotta keep doing it. Okay, so EH is this, so therefore what is EG then? It's 2/3 of that. 2/3 because the ratio is 2 to 1. Why is there crinkling? Okay, and if you distribute the 2/3, what are you gonna get? 4/9 D plus 2/9 W. Okay, now we're almost there. Whew! So now that I got this, okay, like Morrissey said, this plus this equals that. This is the one we're trying to find. So ED, which is D, plus DG, which is the thing we're trying to find, is equal to EG. But EG is this thing right here. 4/9 D plus 2/9 W. Therefore, if you subtract V, DG is equal to what? Subtract V. Subtract V. Negative 5/9 D plus 2/9 W. Boom! This problem is on the quiz. The only thing I'm going to change, I'm giving you the exact same picture. Just instead of the ratio being 1 to 2, I'll make it 2 to 3, whatever, 3 to 5, whatever. All that's going to do is change the ratio. So again, you have to be able to look at a triangle, and however I make the vectors, you got to be able to go what plus what equals what. This plus this equals that. Isn't that the kind of exercises you guys did in physics? What did you do then to understand vectors?
Go across the stream.
Just memorize. See, that's the problem. If you guys haven't figured this out yet, this class you cannot memorize. You gotta learn. What happens when you memorize? Pain, that's what happens. Okay, next, 6 and 8. Okay, 6. We forgot polar coordinates, huh? Given the polar point P, which is 420 degrees, and the origin, which is 0, 0 degrees, if you want to put that, give the component form of OP. Are you joking? Draw a picture. Okay, here's the origin. Okay, how do you plot the point 420 degrees again in polar coordinates? You measure off an angle of 120 degrees, and then you go 4 units from the origin. Okay, now what you want to do is you want to change it to rectangular coordinates. How do you change from polar to rectangular? You guys remember? No, just change from polar to rectangular. X equal R cosine theta, Y equal R sine theta, right? Does that look familiar? Okay, so what's the X coordinate? This times the cosine of that. What's cosine of 120? Negative half times 4. What's sine of 120? Root 3 over 2 times 4. 2 root 3. So it says, write the component form of vector OP. How do you componentize vectors? Head minus tail. What is this minus 0? What is that minus 0? There you go. That's how you componentize. Head minus tail. But the coordinate, the points have to be in rectangular form. So if it's not in rectangular form, you change it to rectangular form. Oh, Mr. Park, whenever the tail is at the origin, then the components of the vector is the same thing as the coordinates of the point. Duh, that's because you're subtracting 0. That's why, right? And then number 8. Find a unit vector. What is a unit vector? This is a very important term, when you take physics and engineering. A vector that has a length of 1. Unit, just like unit circle has a radius of 1, right? Write a unit vector that has the same direction as this vector right here. Okay, so this vector, if you want to draw it, it has an x component of -4 and a y component of 3. It looks something like that. What is the length of this vector right now? It's the square root of this squared plus this squared, which comes out to 5. Okay. What can I do to this vector to make it have a length of 1? Well, you multiply it by 1/5. There you go. Boom. Done. Doesn't that make sense? If it has a length of 5, if you multiply by 1/5, then it has a length of 1. So if you want to distribute the dice to -4/5, how about 3/5? The concept of unit vector is very simple, but it's super important in physics and engineering, as we'll find out. Okay, so this is just the beginning of, this is like just the basics. All you did last night was learn how to multiply by a number and add vectors. That's the most important, adding vectors. How do you add? This plus that equal that. You gotta keep, and if you're having a hard time, you just gotta do that over and over. Maybe you guys should do the example in the notes. That might help. Oh, wait, I have it right here. Okay, but this is the second page of the note. Okay, today we learned how to multiply vectors. Okay, so we know how to multiply a vector by a constant. We know how to add. Now we gotta multiply. But the problem is, you guys in physics should know this. How many different kinds of multiplication are there in vectors? And who's in AP physics? You guys should know this. Nobody wants to admit that? Takaki, how many different kinds of multiplication are there?
3.
No. 2. Oh my goodness. If you have two vectors, there's two ways of multiplying them. One is like that. That's called the dot product. The other way is this. This is called the cross product. Yo, Mr. Park, doesn't that simple just mean multiply? Yeah, but there's two different kinds of vector multiplication, the dot product and the cross product. Today we are going to learn the dot product. Because in order to learn the cross product, you got to do 3 dimensions. You guys in physics, did you learn the right-hand rule yet?
Yeah.
Oh, see, you know something.
Thank you.
What? Oh my gosh. Okay, the dot product, by definition, is equal to the length of the first vector times the length of the second vector times the cosine of the angle formed by the two vectors. Exactly. And you guys in physics, as soon as you see that, you should be thinking that's work, right? FD cosine theta. This is work. Oh my God. Okay, so for example, let's say we have a vector A. Let's say the length of it is 4. Here's vector B. The length of it is 3. This angle, now remember, vectors, you can move it all around as long as you have the same length in the same direction, right? So you can always put two vectors tail to tail, right? No matter where you are. You can always just grab them and put them tail to tail. This is theta, the angle formed by the two vectors. Let's say that angle is 60 degrees. What is the dot product of these two vectors? According to the definition. It's the length of the first vector times the length of the second vector times the cosine of this angle. And what is the cosine of 60 degrees? 1/2. So you get 6. The dot product is 6. It's a number. It's a scalar. That's why some books call this the scalar product. Because when you multiply two vectors in this fashion, you get a scalar as your answer, just a number. But you can do lots of things with this number. See, that's the thing. Now, see, the problem with this, if you know when you're drawing pictures and stuff, if you're going to compute the dot product, you got to compute the length of this vector, you got to compute the length of that vector, and then you got to measure the angle between the two. So I'm going to state the theorem over here. If two vectors are in component form, so if vector A is in component form, let's call it A comma B. If vector B is in component form, let's call it C comma D. Then to compute the dot product, this is all in your notes, by the way. All you have to do, you multiply the x components, you multiply the y components, and then you add them together. Right, physics people? No, isn't there a section in your physics book that has like all the vector operations? Isn't this in there? So what do you do to compute the dot product? You measure the angle, take out a protractor. Or they give you the angle. Okay, but that's not going to happen now. Okay, so do you guys understand this? Okay, here, let's do an example. Vector u is equal to 1, 2. These are the x and y components. Vector v is 4, negative 3. What is the dot product of these two vectors? Well, you multiply the x components, you multiply the y components, and you add them together, and you get, yeah, that's the dot product. That's the answer. Yeah, it is easy, except now we're going to use it to solve problems. See, the thing is, well, what is the meaning of this number? Well, it's the dot product. Like for work, what's the units for work? I forget. Joules? Just joules. No. It's Newton meters. Force times distance, that's why, right? It's Newton meters.
Lots of power.
What's a joule?
Work, sorry.
Joule is work.
Joules.
Joule is work.
That's a joule.
What is it? BTU?
British thermal unit.
Yeah.
I don't know.
Wait, joules is energy.
All I know is they measure air conditioners in BTUs. Okay, whatever. Okay, let's do a problem.
It's kinetic energy in joules.
Let's say you have a triangle in the Cartesian plane. Now, probably, I don't know. Let's just do it. Here's a triangle in the Cartesian plane. 2, 1, just make up some numbers. 7, 3, and then how about 5, 6? Okay. Which angle do you want to find? A, B, or C? Pick one. Okay, A. Using vectors, compute the measurement of angle A. Well, what are we learning? We're learning the dot product here. In fact, whenever you work with vectors, anytime you want to find the measurement of an angle, the dot product is your tool. Okay, because look, theta. Okay, so what two vectors form angle A? Okay, AB, make sure you get the vectors pointing the right way now. And vector AC. Would you agree they form angle A right here? Okay, let's componentize each one. What is vector AB in component form? Nakasone. Is that correct? Or it should be -5, -2? Or it doesn't matter?
That's right.
Yes, it matters. Yes, because of head minus tail when you componentize. So 7 minus 2, 3 minus 1. That is correct. Okay, how do you componentize vector AC? Morris.
3, 5.
See, this is what you should have got from last night's homework, right? Head minus tail. If you go tail minus head, your vector's pointing the wrong way. You just got fired from your engineering job. So if I want to compute this angle right here, all we got to do is use the dot product, the definition. In fact, let's move it around. So therefore, the cosine of an angle is equal to the dot product of the two vectors divided by the length of the vector A and then the length of vector B. Right? If you take this and divide. Okay, so if I want to find that angle, the cosine of that angle is the dot product of these two vectors, but if they're in component form, I just taught you, how do you find the dot product? You multiply the x components, you multiply the y components, and you add. So what is that, 15 plus 10? Okay, I just put 15 plus 10 for your viewing pleasure. All over the length of this vector. Now, how do you find the length of a two-dimensional vector? It's the square root of this squared plus that squared. See, that's why, if it's in component form, it's so easy. What's the square root of 25 plus 4? Root 29. And the length of this vector would be the square root of that squared plus that squared. Root 34. So therefore, that's 25 over root, oh my gosh, 34 times 29, 6 carry 3, 8 carry nothing, 6, 8, 9. Did I do that correctly?
Of course, you are the teacher.
Because there's no common factors, right? So tell me, what is the measurement of this angle then? Cosine inverse 25 over root 986. There you go. And of course, that can be punched in on your calculator, right? But you're not going to have a calculator on this test. So you just leave it like that. Unless I make it come out nice, like cosine inverse negative root 3 over 2 or something. so what did we just learn here? Whenever you want to compute an angle, you use the dot product. You just do what I just did here. So you form the two vectors that make that angle, and then you use the dot product. Now you might be saying, Mr. Park, I got a better way. I'd rather just find the length of the sides and use the law of cosine. Yes, but the problem is what happens when you get to 3 or higher dimensions? That's why you want to use the dot product. Okay? Yes, in 2 dimensions there's all kinds of different ways, but when you get to 3 and higher, you want to use the dot product. You're going to find out. Okay, last thing. How can you tell if 2 vectors are parallel? Try and then look. Okay. Yeah, write that down on the test. How do you tell if 2 vectors are parallel? Okay, somebody said slope. But see, slope is a 2-dimensional concept, right? What happens when we get to 3 dimensions? Is there such thing as slope? No! What about 5 dimensions? No. So what do? Slope is a 2-dimensional thing.
The components are
Okay, here. So here, let me give you an example. Let's say this vector is 3, 2. It has an x component of 3 and a y component of 2. Let's say this vector is 6, 4. Are they parallel? Yes, why? And you better not say they have the same slope. Because what? One is a multiple of the other. That's right. So, how do you tell if vectors are parallel? One is a multiple of the other. And if you think in 2 dimensions, yes, they have the same slope, if it's 2-dimensional. But once we hit 3 dimensions, there's no slope. We laughed out of the dormitories. How do you tell if 2 vectors are perpendicular? Flip. They have negative reciprocal slopes. Yes, in 2 dimensions, okay, that would be fine. But what about 3 dimensions? Okay, for example, okay, here's this vector here. Okay, let me draw another one. Let's draw like this. Let's say the components are -2, 3. No! -2, -3. No! Wait, that's not right. -2, 3, there you go. Is this, well, we know these two are parallel right here. Is this vector perpendicular to these? Okay, yes. Why though? Very good. See, now you guys are thinking. The dot product is 0. Not because they have negative reciprocal slope, because again, once you go past 2 dimensions, there's no slope. The dot product is 0. How do you find the dot product of this and this? What did we learn today? You multiply the x components, -6. You multiply the y components, and you add them, you get 0. So why is it when the dot product is 0, they're perpendicular? Well, just look at this definition, or this one. Both of these are the same thing, right? What would happen if the dot product is 0? That means this fraction is 0. So if the cosine of an angle is 0, doesn't that mean the angle is 90 degrees? So that's why. So that's how you tell if 2 vectors are perpendicular. The dot product is 0. Are we getting the hang of it? Yeah, so, yeah, you can think 2-dimensionally, that's fine, but tomorrow we start 3 dimensions. Now, I understand in geometry you guys learn x, y, z axes. How come some people went like this and some people not even on it? Oh, Mr. Masunaru made you make the thing. The x, y, z axis. With chopsticks.
No.
Okay, good. And what about the other geometry people? Kobe. Takaki. Just keep staring again.
I remember like very little. Like I remember there was like this fly in the room, and like the fly's in the corner of the room, like the right where the fly was.
In the corner, huh?
Like in 3 dimensions, like the coordinate where the fly was. Remember that? That's how it was.
Sasaki.
I remember.
Okay, well, anyway, tomorrow we're going to learn 3 dimensions. That should be fun. Okay, we're done then. And of course, once you get to 3 dimensions, then you can do 4, you can do 5, you can go 6. Okay, the bell rings in 10 minutes.
I don't know why. Every time I still see it.
Okay, so tonight's lesson is kind of easy, you know. Tomorrow, then it starts getting hairy.